Am I audible?
Yes, sir.
Okay. Is my screen visible?
No, sir.
I'm sharing it now. Just check now.
Yes, sir, it is visible, sir.
Okay. Shall we get started then? Listen. Done. Sorry. Listen. So in the previous class, we discussed about this one, right? I told you this is important also. What is it? This is called as the phasors and the phasor diagram, right? So what does a phasor represent? I told you what is a phasor. It's a rotating vector. And why do we use that rotating vector? To represent something. To represent the... So what do you mean by sinusoidal waves? Function of sine and cos. So anything, any parameter written in terms of sine or cos is what is called as a sinusoidal function. Okay. So it is a rotating vector that represents a sinusoidally varying quantity. That's what is called as a phasor. And there is something called as a phasor diagram. So what is a phasor diagram? That vector, along with the representation of vector, you need to do few other things. What is it? First thing, when you talk about that vector, right? So when you talk about the vector is going to have some magnitude associated with it. What is the magnitude of that vector represent? The magnitude na length da. Amplitude. Okay. So magnitude of the vector is going to represent the amplitude of the physical quantity. So what are the two physical quantities we'll be concerned about throughout the chapter? There are only two things, EMF and the current. In the sense, for the given input EMF, what is the output current we are going to generate? If you understand this basic, it's enough. So what is that we are going to do? E is equal to E naught sine omega t. So for the given input of E, what will be the output current? Which will be I is equal to I naught sine omega t, or it can be like this also. Omega t plus or minus 5 also will write. I think I discussed that in the previous class, right? So here, what is going to happen? Tell me. Listen. Yeah. So the magnitude of the phasor, if I take this to be the phasor and this is the one which is rotating, generally you take the rotation in the anti-clockwise direction, right? So let's say the phasor is like this, and imagine that this is broken into 4 quadrants. So the phasor is going to rotate in this way. When it is rotating, it is going to make some angle with respect to the x-axis. So what is the magnitude of this? It is the amplitude of this physical quantity, which is E naught, right? Then how do you find the instantaneous values? Then how do you find the instantaneous value? I use something called as dropping perpendiculars. That has a special name. What is it called as? Projections. So if you project the vectors endpoints onto the axis, that is going to give you the instantaneous values, right? And the diagram which has all these things in it is what is called as a phasor diagram. So how is the phasor diagram going to be represented? If you take E is equal to E naught sine omega t, which is the input, and I is equal to I naught sine omega t plus phi as the output. Remember, not necessary that always phi will exist. Phi can be 0, or it can be minus, or it can be plus also. And I told you what is the name of that phi also, if you remember. That is called as initial phase. It's called phase difference. It's called as the initial phase, or you can also call it as, I used the word EPOCH, if you remember, it's called epoch, right? I use this word, right? See, most commonly that is not used, but for your knowledge, I'm just sharing it. You call it as the initial phase. Now listen to this carefully. If I want to draw the phasor diagram for E, what am I supposed to do? We'll assume that the E value is lying like this. the E vector is lying like this, you need to start rotating it in the anti-clockwise direction. And where are you supposed to stop it? You need to stop as soon as it makes an angle of omega t. Meaning, if I start from here, I will stop the E vector as soon as it makes an angle of omega t, but this omega t is made in the anti-clockwise direction. That's what I've represented here. So that this length OA is going to be A naught, and the projection dropped. That is, if you drop the perpendicular from A onto the y-axis or x-axis, will give you the instantaneous value. In this case, see, most of the cases, what will happen is, if you drop a projection onto the x-axis, the projection will give you cos function. If you drop the projection onto y-axis, it will give you the sine function. Here, what function are we using? We are using sine. So that is why we will drop the perpendicular onto the y-axis. When you drop it, I gave this logic also, if you remember, right? This distance is y. What is y divided by E naught called as? If I take the triangle, if I take this to be M, if I take the triangle OMA, this distance is y. How much is this angle? Omega t. And how much is this length? It is E naught. Y, what is y divided by E naught? Y divided by E naught is equal to sine of how much? Omega t. So y will be equal to, rearrange it, E naught sine omega t. But what is E naught sine omega t according to physics? This is according to mathematics, trigonometry. But what is E naught sine omega t according to physics? It is the instantaneous value. So that is why if you see, the projections are going to give you the instantaneous value. Similarly, how are we supposed to draw the graph for, how are you supposed to draw the phasor diagram for I? Same logic. I will also lie on the x-axis. So what is the angle made by I? It is not omega t, rather it is omega t plus phi. Means after you complete a rotation of omega t, you need to rotate it through an angle of phi, even more extra in the anti-clockwise direction. When you do this, you will stop it at a certain point. But remember one thing, the magnitude of I naught will generally be less than E naught, because output should be less than the input. It cannot be 100% efficient, or it cannot be more than that. That is why if you see, whenever we draw the phasor diagram for I, the value of I naught will be small compared to E naught. E naught is this much, I naught is this much. In the case of initial phase curve, in general, if you write it, it is initial. In this case, it is a phase difference. So it is already having a phase difference of phi. So phi, it is not starting from 0. Actually, on the phi the meaning it is somewhere here. In the phi in the phi you draw that omega t extra, it will come and stop here. So in this case, what is happening is, this phi is there, no? That phi is what is called as phase difference. Did we see that? You would have written it. So now you will understand what a phasor diagram is. But here, one important point to be kept in mind is, you can draw the phasor diagrams only the frequency of the input and output are the same. What should be the same? The frequency. That is, here also it should be omega, here also it should be omega. Am I right? Now listen to this carefully. A diagram that represents alternating current and voltage of the same frequency as rotating vectors, along with proper phase angle between them, is what is called as phasor diagram, or it is also called as Argand diagram, because there is not something that exists. This is drawn for us to understand what are the phase difference. I told this logic also. EMF and current, they both are actually not vector quantities. But we are taking the help of vectors only to understand some mathematical operations happening between them. Is this point clear? This is the first and the foremost point you need to understand for me to proceed with the other topics. This is not clear, I cannot proceed. Is there any doubt in this? Is everyone clear with it? Right? Now, let's get started with the next important topic. Okay. It is this thing. So write down the heading. So write down the heading as AC circuit containing only a resistor. AC circuit containing only a resistor. Okay, listen to this carefully. Sorry. Now listen. Guys, I want you all to concentrate. Listen to this carefully. Listen. Listen. Done? Listen. So if you look at the topic, right, what is there? You have an AC source. What is the AC source here? This one, the circle and with that sine wave inside, right? You have an AC source which is connected only to one passive element. What is that passive element here? It is a resistor. So all that we need to observe is you are giving some input to the circuit in the form of voltage, and you will draw some output from the circuit in the form of current. Am I right? So these are the two things you are going to do. What will you do? You will give some input in terms of voltage and you will draw some output in terms of current. We are going to see the relation between those two. Now observe, it is very simple, okay? This E is equal to E naught sine omega t is there. No, I cannot actually say that this is going to be the particular direction which is fixed. Because what kind of a current are we dealing with? We are not dealing with direct current. We are dealing with alternating current. Means its direction is going to change with respect to time. For every half time period, it will keep changing. For now, what I'm doing is I'm taking this to be the direction for the first half cycle. Am I clear with that point? So I'm taking this to be the direction for the first half cycle. I'm observing what is going to happen in this. Now, if I take the instantaneous value E is equal to E naught sine omega t, then what is going to be the value of I? I will be equal to E divided by R. I is equal to E divided by R because it's a linear element. So E is equal to how much? It is E naught sine omega t divided by R. Can I write it in this way? Now, this E naught divided by R, I'll call it as I naught. This will be equal to I naught sine omega t. That's it. That is all the derivations. So what is happening? You have given an input of E is equal to E naught sine omega t. You got an output of I is equal to I naught sine omega t. So after this, what we will do is we will draw two diagrams. I want you to concentrate them. Okay, we'll be drawing two diagrams. One of the diagrams is going to be called as the phasor diagram, and the second is the graphical diagram or graphical representation. Okay. Now, let me explain, then you can copy it. What is it we got? You gave the input of E is equal to E naught sine omega t, and the output came as I is equal to I naught sine omega t. Am I clear with this? Right? The first condition to be recollected is when can you draw phasor diagram? Only when both the vector quantities, only when both the physical quantities have the same frequency. Is that satisfied in this case? Here it is omega, here also it is omega. So I can draw the phasor diagram. So when I draw the phasor diagram, all that I need to do is I'll take the x-axis, y-axis, x dash and y dash. Clear with this? So for E is equal to E naught sine omega t, if E starts from here, how much should I rotate it through? Through an angle of omega t. So I'll rotate it through an angle of omega t so that if I take this O to A, then OA will be equal to how much? This I've already told you. The magnitude of the vector is going to be, it is E naught. And where should I stop it? After it rotated through an angle of omega t. See, whenever you have a positive angle inside, right? We know that anti-clockwise rotations are positive. That is why we are rotating it in the anti-clockwise direction. I'll stop it at omega t. Now, if you look at the expression of I, what does it state? I is equal to I naught sine omega t, right? So for I will use another color. Listen. Again, I will start from here. Where should it go and stop? The hint is given by this omega t. So I will also go and stop at omega t. So if I draw it like this, then OB will be equal to I naught. Why did I draw the arrow mark there? Because current is the output. I told you output will always have lesser magnitude compared to the input. That is why I drew it in this way. So if I draw the overlapping part, it will be like this. Is this clear? So this phasor diagram is given when you have an AC source connected across a resistive element. If it is only resistor, this is how the phasor diagram will be there. See, the point here is it is easy for us to draw, but sometimes what they will do is the question will be asked in reverse. They'll give you the phasor diagram and ask you what is the passive element across which the device is connected. See, here it is simple. After we see the next two, you will understand what I'm trying to say. So here, what is that you're able to understand? That the EMF and the current, they both are in same phase. This is the language they use. So there is a passive element. Listen to this carefully. There is a passive element across which an AC source is connected. What did I say? There is a passive element. What is the passive element? I'll come to that point. There is a passive element across which an AC source is connected so that the EMF and current are in the same phase. Phases PHASC are in the same phase. What is that passive element? It's a resistor. Because for a resistor, EMF and current, they both are in same phase. What is the meaning of same phases? Both of them have omega t. That is the meaning of same phase. Are you able to understand this point? So EMF and current are in the same phase. I hope I'm clear. Right? So first copy it till the phase diagram, then I'll tell you how to draw the graphical part. Okay. Write it down. Finished. Done. Next slide. Huh? See, copy the diagram that I drew. Don't copy it from the printed one. Done. Not coming. Let me know once you're done. Guys, this is a very simple topic. Are you done? அந்த இது மேல லோட் போடாதடா. Done. Done. So listen to this. See, the next part is, once we are done with phasor diagram, கேக்குதுண்ணா? வாய் மூடிட்டு. Okay, listen. So once you finish the phasor diagram, the next part is understanding how to draw the graphical representation. So as I told you, for phasor diagram, there is no time or any value, any parameter taken on the x or y axis. It is just x axis and y axis. Okay. Whereas when you draw or represent it graphically, you need to represent E and I as a function of time. So E comma I is taken on y axis and time is generally taken on the x-axis. Okay. So rather than time, you can also take omega t. Omega t represents the angle. It's simpler because omega t, if you take it as angle, we can write the graph's values in terms of the radians itself. Now listen to this carefully. When I draw the graph for E is equal to E naught sine omega t, how is it going to look like? I'll draw it. Listen. So what is the input? E is equal to E naught sine omega t. What is the output? I is equal to I naught sine omega t when you connect the AC source across a resistor. Take the graph, omega t here. You take E comma I here. Right. For E is equal to E naught sine omega t, how will the graph be? It will be a sine wave. Accepted? So I've drawn only one cycle. The same pattern keeps repeating itself. Okay. So if I check what this height is going to be E naught. And what is the name of this graph? It is E naught sine omega t. Right. Like the way you drew the phasor diagram, where on the same phasor diagram you drew for E and I. Right. Here what we'll do is we'll draw the same graph for E and I on this itself. So when I say I is equal to I naught sine omega t, it will be taken like this. So it will be taken like this. So what I suggest is, generally when you're drawing the graph for E, draw it as a continuous graph. And when you're drawing for I, draw it as a dotted graph. Okay. So the name of this dotted graph is going to be I naught sine omega t. And what is this value going to be? From here, if I drop a perpendicular, how much will this value be? It will be I naught. Am I clear with this? Right? So this is how it is represented. This is the graphical representation for what? Again, this is the graphical representation for AC source connected across a resistor. Okay. So make a note of it. Are you done copying? So I hope this is simple, right? Did you understand this? So when you, what are the things you are supposed to do? Going forward, this is what we are going to do for all the circuits, right? However, whether it is a complicated circuit or a simple circuit, all that we need to do is first understand the relation between, what is the first thing I did? Understand the relation between EMF and current. Second step, draw the phasor diagram representing the relation between the EMF and the current. What is the third step? Draw the graphical representation. That will give you some idea. Right. Having said this, we'll proceed to the next subtopic. So I'll come to the inductor at the end. We'll start with the capacitor. Okay. So the heading is going to be AC source containing only a capacitor. So we'll try to understand how the EMF and current are related when you have the AC source connected only across a capacitor. Okay. Okay. This is going to be the diagram. So did you write the heading? AC source connected only across a AC source containing only a capacitor. AC source containing only a capacitor. So this is the diagram. So in the previous case, what was a passive element? It was resistor. In this case, what is a passive element? It is a capacitor. So here, what will happen with respect to a capacitor is, see, let's first think of the logic. When the direction of current is in this way, when the direction of current is in the clockwise path, what will happen? Let's say the capacitor is first getting charged. So what is the property of a capacitor in the first place? If somebody asks you, why do we use a capacitor? What will you say? It is to hold the charge, right? So when it is getting charged, there will be, this plate is going to have positive charge and this will have negative charge. During the reverse cycle, what will happen? It will get discharged. So first it will get charged, again discharged, charged and discharged. Unlike resistor. In resistor, there is no concept of charging or discharging. It will only dissipate the heat. It will take use of the power that is being given to it and will start dissipating it. Is that clear? Now the point is, let's say at some instant, the charge that is there on the capacitor is Q. So the charge that is there on the capacitor is Q. What is the input you have given? E is equal to E naught sine omega t. So E is equal to E naught sine omega t. Right. So what did I say? I need to find what is the value of current, which is coming out to be instantaneous. Listen to this. We know the relation between charge stored in a capacitor and capacitance and voltage. So we know this, right? Q is equal to CV. We have discussed this. So Q is equal to CV means C into, in the place of V, I can write it as E in this case. Because there is no resistor here, there is no dissipation taking place. So potential difference will be equal to the EMF that I'm talking about. So C into, what is the value of E? So is this one step clear? Okay, is this one step clear? But my interest is not about charge. My interest is about current. So if I know the instantaneous charge, how do I find the instantaneous current? So dq by dt is going to give me the value of I. So if I differentiate it, observe, C into E naught is a constant. Sine omega t is there, no? So what is the derivative of sine omega t? It is cos omega t into omega. Integrals nalla poiruk mandayil. Into thanda varum. Chain rule. Derivative thanda pannirukku. So listen, I is equal to C E naught into cos omega t into omega, right? So I've applied the chain rule here. Clear with this? Right. Now observe, I'll combine this omega and C. I will write it as omega into C into E naught. Can I write this as cos omega t? Right. Now see, This E naught, I will leave it as it is. This omega c, I will write it as 1 divided by omega c. Makes sense? I brought this omega c to the denominator. It will become 1 by omega c into this cos omega t is there. No, for cos, I will write it as sine of something. But this is where the tricky part is. If I have cos theta, I can either write it as sine of 90 minus theta. Right? Sine 90 minus theta is cos theta. So I can write it as pi by 2 minus theta, or I can write it as sine of pi by 2 plus theta. Both are same. Okay. But here in the place of theta, what do I have? I have omega t. So if I take these two concepts, I can either write it as sine of pi by 2 minus omega t, or I can write it as sine of pi by 2 plus omega t. Can I write it like this? It will be plus. Just because you asked, sine pi by 2 plus theta is there. No, forget about second quadrant, third quadrant, whatever it is. Tell me what is sine A plus B. Sine A cos B. So sine pi by 2 is 1. 1 into cos theta. Cos pi by 2 is 0. Satisfied? Is that clear? If you forget, you can think in this way also. But whenever you're taking complementary angles, just to tell you, if it goes pi by 2 plus theta, you need to see what is this function. In the second quadrant, sine is positive. That is why cos becomes positive. You should take that second quadrant or third quadrant when you take the multiple of pi, not pi by 2. Okay. Okay. So I'll come back to this. Are you clear with this concept? So there is a reason why I'm asking this. Are you clear with this? Cos theta is equal to sine of pi by 2 minus theta, or sine of pi by 2 plus theta. So I can write either of them, but which one should I choose? I cannot write both. I can use only one of them. Which one should we use? Should I use the first one or the second one? I'll give you the hint. The answer to that lies in the definition of phasor diagram. No question. No answer. I gave you the hint just now. First, KBC first option, second option. I gave you the hint already. What did I say? You're looking at something else. Not the question about. Listen to me. Whether I need to choose the first one or second one, the hint lies in the definition of phasor diagram. Why? Why second? That is the reason. Did you understand what she told? Did you all write the definition of phasor diagram? Go and check. What is it I gave? When can you draw a phasor diagram? I told you today also. When can you draw the phasor diagram? I told you to underline one important point. Same frequency. So what is the input frequency? It is omega t. Whereas if I take sine pi by 2 minus omega t, the frequency of the output will become minus. Whereas if I take sine pi by 2 plus omega t, it will still be plus. So which one should I choose? So I should write it as sine of pi by 2 plus omega t, to be more specific, because I want the answer to be in terms of I naught sine omega t plus phi. I will write omega t first, so that you will get more clarity. So E naught divided by this omega c has 1 by omega c has a name. I'll tell you what it is. So it is 1 divided by omega c into sine of, can I write it as omega t plus pi by 2? They both are same, right? So this will be I. Now can I write this E naught by 1 by omega c as I naught? So this will be equal to I naught sine of omega t plus pi by 2. Am I clear with this? Where I naught is equal to how much? It will be E naught divided by 1 by omega c. Right? This 1 by omega c is given a name called as xc, x with a subscript c, and this is equal to 1 by omega c. Any idea about what is the name of this? It's called as capacitive reactance. See, in the previous case, you would have seen E naught by R would have come. R is the resistance. So resistance is a term used for devices where only resistors are there. So if it is a pure resistive circuit, then the opposition offered by that circuit is going to be resistance. If it is a device like this, if it is a device which is a capacitor or an inductor, the resistance offered by those devices is called as, you don't call it as capacitive resistance because resistance is used only for resistors, you call it as capacitive reactance. So it is an equivalent quantity of resistance for a capacitor. If you add the prefix of capacitive, it will be for a capacitor. If it is for inductor, which we'll be discussing next, it is called as inductive reactance. Why we call it as resistance is because current and that parameter are inversely proportional to each other. So if the value of 1 by omega c increases, the value of I naught will decrease. Am I clear with these points? Am I clear? So just to conclude, what is the value of E? E is equal to, what is the input we gave? E naught sine omega t. What is the output we got? I is equal to I naught sine of, we got something else. We got I naught sine of, yes, we got omega t plus pi by 2. Now what do we need to do? We found the relation between the input and the output. The next step is to draw the phasor diagram, and the third step is to draw the graphical representations. Actually, if you see, the concept is simple only. I'll just summarize it. What are we supposed to do? First, you need to draw the diagram. If suppose this question is asked in the exam, you first need to draw the diagram. You need to say that the input value E is equal to E naught sine omega t. And how will you get the output? First, you'll write the expression for charge. After you write the expression for charge, then you need to differentiate it with respect to time. When you differentiate with respect to time, you will get current. Okay. So after you get the value of current, mostly when you differentiate sign, right? When you differentiate or integrate it, sign will become cos. Right? So in this case, you will get cos. Cos should get again converted to sine. And then you need to proceed so that you will get the final expression for current in terms of sine itself. If input is in terms of sine, output should also be in terms of sine. Had you started with cos, you should write that in cos and leave it. Okay. So are you all clear? So first copy this. We have written this, right? Now listen. So what is the second step? We need to draw the phasor diagram. Are you done or you want to copy? You're done? Okay. So the second step is phasor diagram. If you take this to be x, y, x dash, and y dash, right? So E is equal to E naught sine omega t. E is going to start here. Where should I stop? So anti-clockwise rotation of omega t, right? So this is OA, right? Now for current, what am I supposed to do? For current, what should I do? From this OA, I need to rotate 90 degrees more. So you need to rotate it 90 degrees more. So what will happen? It will be like this, right? So that this angle is going to be 90 degrees, right? If I take this to be OB, OA is going to be E naught and OB is going to be I naught. Am I clear with this? Right? So this is going to be the phasor diagram when an AC source is connected across a capacitor, right? So here an important point to be understood is, if you see which one is leading, which one is more compared to, is having more angle compared to the other. Current is having an angle of pi by 2 more compared to the EMF. So here how you write is, you write the statement as current leads the voltage, current leads the voltage by pi by 2. Current leads the voltage by pi by 2, or you can write voltage lags the current by pi by 2. So it can either be current leads the voltage by pi by 2 or voltage lags the current by pi by 2. Is the point clear? Right. So they will ask you, in the previous case, what happened when you drew the graph between EMF and current? Okay, when you drew the graph, phasor diagram between EMF and current, what happened? The current and the EMF, they both were in the same phase. Whereas when you're drawing the phasor diagram for EMF and current for a capacitor, what is happening here? They're 90 degrees out of phase, but which one is leading the other? Current is leading the voltage by pi by 2, or voltage is lagging the current by pi by 2. Okay. Are you able to understand? No. As active voice is passive voice. As inductor. Inductor. This is capacitor. I am inductor. I know in capacitor. First draw this. இருக்கா உயிரோட இருக்கா Done. Are you done with this? So the next is going to be graphical representation. When you draw the graph, what did I say you will take on the y-axis? It is going to be EMF and current. And what will you take on the x-axis? It will be omega t. You will take the angle itself. You will take omega t, right? So when I draw the graph for EMF, see, for EMF, the graph is fixed because always the input is going to be E naught sine omega t. Only the output will keep changing its value. So this will be equal to E naught sine omega t. Am I clear till this point? Now the next question is, how should we draw the graph for I? Right. So what is the value of I? I is equal to I naught sine of omega t plus pi by 2. See, one of the biggest mistakes that is done is we see omega t plus pi by 2. Most of them will start shifting the graph by pi by 2 and start drawing it from here. But remember, the graph will get shifted to the left by pi by 2. The graph will not get shifted to the right by pi by 2. Okay? Meaning, I should start the value of I from here itself. So the same kind of a graph will come, but it will start from the left and it will look like this. Meaning, when the current is when the voltage is least, current will be maximum. When the voltage is maximum, current will be least. It keeps changing because they are always out of phase by an angle of pi by 2. Is the point clear? So this will be, if I drop a perpendicular from here, this distance is going to be I naught and this distance is going to be E naught. Is that clear? So this is going to be the graphical representation for which one? When an AC source is connected across a capacitor. So this is all about AC source connected across resistor and capacitor. Right. Next point that we need to see is about when an AC source is connected across inductor, that we'll see it in the next class. After that, we'll see the combination in the sense what will happen when you have an RL circuit, RC and RLC circuit. Okay. So tomorrow mostly we'll be seeing 2 more concepts. So just go through these concepts and come. Those are online, are you clear?
Yes, sir.
Okay.
Sir,
Yeah, tell me.
sir, I have joined at 5:10, sir, in maths class, sir. What had happened before that, sir?
No, nothing. You joined at the right time. You told you my voice was not audible, no?
Yes, sir.
That time only I said.
Okay, sir.
Yeah. ஆகாது. ஏன்னா வந்து அதோட மேக்னிடியூட் இங்க ஓட்ட பவர் வந்து ஆன்சர். இங்க ஓட்ட பவர் they both had the same magnitude. They could have been the same magnitude. வேற அப்ப இது பெண்ட் ஆகுறதுனால கொஞ்சம் உள்ளதான பெண்ட் ஆகும். Yeah.
Thank you, sir.
Yeah.